All right, hello college algebra. So we are moving on into, we're continuing with properties of logarithms. We're going to look at 3 additional properties on top of the 6 that I've already given you. So let's have a look and see how we use them and so the applications of these properties. So if we keep going and we add on these properties, the next one in the list that we've been looking at says if you have a log of 2 things being multiplied, that's going to equal the same as 2 logs of addition, like this. And notice one thing to make a note of: equal signs work in both directions. So to give you an example, let's just say we have the right hand side. Let's just say we had log base 2 of, say, 1/2 plus log base 2 of 16. We have both of these. We could write this as 1 log of multiplication. So log base 2 of 1/2 times 16. So that would be equal to log base 2 of 8. So these two separate, if you were to, let's just look at the math here for a second. If I was to do this log on my calculator, I would get -1. If I do this log on my calculator, I can do it in my head. 2 to what power is 16? I get 4. -1 and 4 is 3. And then this was the first log that I taught you. 2 to what power is 8? 3. So you can see that those expressions are equivalent, okay? And there's many different ways we could do this. So again, the one question might be, so we'll start with example 1, rewrite as 1 log. So you might have, so on part A, you might have log of 7 plus log of 9. You're going to say, okay, well, how can I write it as 1 log? So since it's 2 logs of addition, it's 1 log of multiplication. So it would be log of 7 times 9, which is log of 63. Okay. And again, you may say, well, check this. You would type this in on the calculator, you type that in on the calculator, and let's see what the decimal should be. So if you do log of 7 plus log of 9, you should get the same as log of 63, which is 1.799. Okay, so whether you do these two or you do this one, those answers should be equivalent. So that's one type of question, one type of problem that you would be asked to do. All right. Then on the other side will be maybe to reverse it. Maybe you have some things multiplied and then you want to expand the log to make it many logs. And these are all, you're saying, well, why would I need to learn this? Well, if you were to move on in mathematics, then these are simplifications that we have to make in, say, in calculus to make a problem easier to work. This is one main use of it. So we'll basically be moving left to right. So let's say I had something like, say, log base 4 of 16 times x. Well, and the question may say to expand on this part, expand. So I know it's a log of multiplication. I can make it 2 logs of addition. And there's nothing I can do with log base 4 of x because we don't know what x is, but here we can answer this 4 to what power is 16 and we get 2. So it also allows us to simplify a little bit further, okay? All right, so this is one additional property. The one that is very similar to this, if you have division, 1 log of division is 2 logs of subtraction, and it would work pretty much the same way, okay? So if I were to go to example 2, and part part A might say rewrite as 1 log, and I might have log base 3 of 45 minus log base 3 of 9. Okay, that might be what we have. All right, now let me make this log base 3 of 5. Okay, so rewrite it as 1 log. Well, 2 logs of subtraction is equivalent to 1 log of division, and then you would actually need to work that out. So 45 divided by 5 log base 3 of 9. And then you could actually answer this. So if it's one that you can answer without a calculator, you're going to say, okay, well, 3 to what power is 9? You should get 2. If you type each of these in separately and subtract it, you should also get 2. Okay? All right. So that's one use. I don't know why I put B there. Now it's part B. And maybe this one could be expanded. Maybe we have ln of 8 over y. Well, if we're going to expand it, now we're going to go from 1 log to many logs. So now I'm working left to right. So maybe I would say ln of 8 minus ln of y. Okay. And that's expanding. There's our answer. Okay. All right. The last property of logs, which you're going to use, says that if you have a log of something to a power, then that power can be moved in front as a coefficient. Or if you have a coefficient, you can move it in as an exponent. So to show you how this property works here, I'm running out of room. My borders here. All right, so we'll erase these. All right, we'll call this one example 3. All right, so let's just see what might the question be. Maybe we would have something like this. So 4 log base 2 of 3. All right. So just to show you that this can be written as log base 2 of 3 to the 4th. Okay. So that 4 can move there. So this is log base 2 of 81. So if I were to type both of these in on the calculator, I should get an equivalent answer. Let's try another one here. Let's just say we had 2 times log base 4 of 8. All right, that should be the same as log base 4 of 8 squared, which is log base 4 of 64. So let's see. I know that log base 4 of 64 is 3. 4 to what power is 8? Well, this is 1.5, and when you double it, you get 3. Okay? So 2 times 1.5 is 3. So those are equivalent. Okay? So that's one way it can go. The other way is maybe I have log base 5 of x squared, and I don't want to have an exponent on the inside. I want to simplify the inside. This 2 can go in front. 2 times log base 5 of x. Okay? So you just see the movement of where if you have a power, it can go in front. One other one here, let's just say I have log base 4 of square root of y. Since square root is the same as to the 1/2 power, that 1/2 can move in front. And there's your equivalent. So I'm just showing you the equivalencies, just how can that third property be used. Now, here's where we would probably put properties, the first 2 with the third one. The question might be on example 4, it just may say expand and write with no exponents if possible. Okay, so maybe we have log of 7x to the fourth, okay? So the first thing is when I'm expanding, when I go here, I know I'm going to write from one log to many logs. So either a log of multiplication to 2 logs of addition, or division to 2 logs of subtraction. So I can see that the main operation in there is multiplication. So then I can write this as log of 7 plus log of x to the fourth. So now I've used that first property that we've looked at today, but this has an exponent here, so, and I can only move in front if the entire inside is to that power. So here I can't move the 4 because the entire inside is not to the fourth. Here, since the entire inside is to the fourth, I can move the 4 in front, and there it is, completely expanded. All right, maybe I have a division, so maybe we have ln of 16 over y to the fifth. So that can be written ln of 16 minus ln of y to the fifth. So I've expanded, but then also here, I have an exponent that can move in front. ln of 16 minus 5 times ln of y. And that's completely expanded. The last kind that you'll see with this is quite possibly where you could have both. You know, you may have, again, you may have example 5, expand again. So now you might have a little bit of both. You might have, let's say we have log of 8 times x squared over y to the fourth. Okay. So now I just have to decide which one I want to do, okay? I do 2 at a time. Now for me, anytime I have division in a log, I'm going to go ahead and automatically split it as 2 logs of subtraction. So I'm going to see that if I kind of use the formula here, the whole top is like the u and the whole bottom is like the v. So I can write this as log of 8 times x squared minus log of y to the fourth. So if I'm expanding and I have division, always do division first, okay? Do division, if you have division and multiplication, get rid of the division first. So now I can see, well, it's 8 times x squared. So now I look and now I have a multiplication. So it's kind of like on this expanded, it's like 2 problems in one. So now there should be no more division because I've done that. So now I have a multiplication, and this becomes 2 logs of addition. But remember, on the expanding, the key element that they'll ask you to sometimes is write with no exponents. So if it says no exponents, so if it says expand, but it says it wants you to write the answer with no exponents, well, then that 2 and that 4 have to go in front. So we get log of 8 plus 2 log x minus 4 log of y. Okay? All right. Okay? So that's pretty much the extent of the expanding that you'll do. Now let's look at a couple more where we would work backwards and we would want to condense. Okay. So erase these 2 problems here. So if we want to condense, I think we're at example 5, I'm not sure. Let's just say we're going to condense into 1 log. All right, so we'll do part A. Let's say we have 3 log of x minus 4 times log of y. Now, I cannot make them. So the first thing I want you we have to see is what property are we going to use? We can see it's close to this here. We have 2 logs of subtraction. So if I'm condensing, for the most part, I'm going from many logs to 1 log. So I can see it matches this almost, but you cannot have numbers in front. So if you want to use these properties here, where you can condense 2 logs of subtraction is 1 log of division, I can do this, but I cannot have numbers in front. So the first thing when I'm condensing is I'm going to move coefficients, and coefficients are the numbers in front, in as exponents. I always look to do that first. So I'll move the 3 and the 4 in. So I get log of x cubed minus log of y to the 4th. Then after I've done that, now I can make it into one log. Okay, so always move coefficients in as exponents first. And now, so I have 2 logs of subtraction, that equals to 1 log of division. Okay, there you go. All right, and it could be an addition, right? I could have 3 things added. Maybe I have 2 log A plus 4 log B plus 5 log C. Okay, you can have several. You can have 3 logs. But again, always when I'm condensing, I'm going to move coefficients in as exponents first. So I get log of A squared plus log of B to the 4th plus log of C to the 5th. And then you can just combine 2 at a time. It doesn't matter. So if I combine these 2 logs of additions, 1 log of multiplication, so log of A squared times B to the 4th. Well, now you want to make it 1 log. So again, now these 2 logs can be 1 log where this inside is multiplied by this. So we get log of A squared times B to the 4th times C to the 5th. Okay. And there you go. And that's condensing. Okay. The last thing that you're going to get again is the change of base. So you're going to get asked to use the change of base rule, but I've already taught you that. So for instance, if we wanted to evaluate log base 3 of 17, in the old days on our calculator, we didn't have the ability to make it base 3. So remember how change of base works. I can make this log of 17 over log of 3. And that allows me to then evaluate and get this answer. Okay, so if you type that in, log of 17 over log of 3. So if we do log of 17 divided by log of 3, we get 2.579. Okay, so remember how change of base works. You have log base A of x. You can make it log of the inside over log of the base. This is your change of base rule. So again, if I had log base 5 of 27, well, 5 to what power is 27? It's got to be a little bit bigger than 2, because 5 squared is 25. But if you want to evaluate it, just do log of 27 over log of 5, and crank that out real quick, just to work along. And you should get 2.048. Now, last thing I want to say. To you, I'm thinking that these rules should look familiar. Like for instance, the familiarity I'm talking about is how does multiplication lead to addition? When do you ever do that? Well, I didn't take the time to derive these rules, but if you go back to your exponent rules, all right, so right by this, if I said a to the x times a to the y, well, we know the rule for exponents is if you're multiplying and your base is the same, you can add exponents. So this property of logs has a close relationship to this property of exponents. You actually use this when you're deriving that. So, and then where does division lead to subtraction? Well, if we had a to the x over a to the y, we would get a to the x minus y, and there's your subtraction, okay? So those 2 main properties there come from that, those properties of exponents, okay? So that is your section 5.5 in a nutshell. Hopefully this will give you the ability to go through and work many of those problems, and we're very close to the end of the semester now, so, and good luck.